Good evening. We are Group 5 and we will be presenting on mixtures and compound. I am Nirvani Bridgmahan and these are my group members Melissa De Vera, Amanda Raghavansi, Lindsay Kishun, and Nadia Garden. Let's get right into the presentation.
My name is Lindsay Kishan of Group 5 and I'm doing question 1, definition and characteristics. The definition for our mixtures and compounds. Mixture is a physical combination of two or more substances that are not chemically bonded, whilst compound is a substance formed from two or more elements that are chemically bonded together in a fixed proportion. The characteristics and differences are mixture is not chemically bonded. The composition is variable, meaning the ratio of components can vary. It can be separated physically, and the components retain original properties. Whilst compound is chemically bonded, it has a fixed composition, can only be separated chemically, and the properties are different from the elements that form them.
My name is Nirvani Bridgmahan, and I will be presenting on comparison of mixtures and compounds. Let me begin with composition, which means how mixtures and compounds are made up. A mixture is made by simply combining substances, and they are not chemically combined. Because no new substances is formed, the ingredients can be mixed in any amount. Since mixtures are not chemically combined, they can be separated by various separation methods. For example, salt water might contain a very small amount of new salt or a lot of salt, depending on how much you add. Nothing forces the substances to stay in a fixed proportion. In compound, the elements are joined together by chemical bonds, so they always combine and they cannot be separated. For example, sodium chloride, magnesium, sulfuric acid. That is how they differ in composition. Now, let's look at how we can separate them. Since substances in a mixture are just physically blended, they can usually be separated by physical techniques such as filtration, evaporation, distillation, or chromatography. These methods do not require breaking any bonds. In most cases, very little energy is involved because no new substances was formed in the first place. Separating a compound is more energy because the atoms are chemically bonded. To break these bonds, a chemical change must take place. This is done through processes like chemical breakdown, thermal decomposition, or electrolysis. These methods require more energy because they change the substance back into its original element. We now understand how they can be separated. Let's compare them based on their properties. When a mixture is formed, the substances do not change chemically. They still behave the same way they did before mixing. When elements form a compound, the result often looks and behaves very differently from the elements that form it. For example, sodium is reactive metal and chlorine is a poisonous gas, yet they form sodium chloride, which we use as table salt. Compounds also tend to have fixed melting and boiling points because they are pure substances.
Hi, my name is Nadia Garden, and I will be looking at homogeneous, heterogeneous mixtures and ionic and covalent compound. Homogeneous mixtures. The word homo means same. A mixture that has a uniform composition throughout its mass is called homogeneous mixtures. The diagram below shows salt and water. When the salt dissolves in water, it spreads out evenly, making the composition uniform throughout the mixtures. Heterogeneous mixtures. A mixture which has a non-uniform composition throughout its mass is known as heterogeneous mixtures. The diagram below shows sand and iron fillet. And by using a simple technique like a magnet, shown below the diagram, you can easily separate the components. Moving on to the ionic compound. An ionic compound is a chemical compound formed by electronics attraction between oppositely charged ions, which is created when a metal atom transfers one or more electrons to a non-metal atom. The diagram below shows atoms sharing electrons pairs forming molecules. Covalent compounds. A covalent compound is a substance formed when two or more non-metal atoms share electrons to create a bond. The diagram below shows water, also known as H2O. Atoms sharing electrons pairing form molecules.
My name is Amanda Fancy and I will be presenting the first part of question 3. Now here are some examples of compounds. Firstly, water, also known as H2O, and it can be found in rivers, rain, oceans, and living organisms. Secondly, carbon dioxide, also known as CO2, which is present in the air and released during breathing and combustion. Thirdly, there is magnesium oxide, also known as MgO, formed from burning magnesium stripped with oxygen. Here are 3 mixtures found in our environment: sand and water, oil and water, and sugar and water.
Hi class, hi Miss. My name is Miss Melissa Oliveira and I will be explaining the lab component part of this assignment. So for the first lab report, we did filtration of sand and water mixture. The title for this lab is Separation of a Heterogeneous Mixture, Sand and Water by the Filtration Method. The aim is to separate an insoluble solute from a solvent by filtration. The materials used in this experiments were 2 beakers, which were both 100 milliliter, a filter funnel, a filter paper, sand and water, and a stirring rod, along with a conical flask. This is a diagram that illustrates the techniques or the materials used to carry out the filtration method, which are the conical flask, along with the filter funnel with the filter paper, fold and place neatly inside to collect the residue, while the filtrate, which is the water, passes through the filter funnel and goes into the conical flask. Next, we have the procedure, and this is a step-by-step method that was used to carry out the separation of sand and water by filtration. So, firstly, the filter funnels, beaker, stirring rod, sample of sand, and sample of water were collected and set up neatly. Then, the sand was poured into the beaker of water and was mixed together. A mixture of sand and water was prepared in a beaker and stirred with a stirring rod. After that, the filter paper was folded into a cone shape and placed snugly inside the funnel, and it was then moistened with a small amount of water to create a seal against the funnel. Then the funnel was placed securely over the conical flask. The mixture of sand and water was carefully poured down into the funnel onto the filter paper. An observation was then made to ensure the mixture did not go above the top edge of the filter paper. And gravity was allowed to pull the water, which is the filtrate, through the filter paper into the conical flask. And lastly, observations were recorded regarding the appearance of the original mixture, the residue on the filter paper, and the collected filtrate. After the procedure, the observation regarding the experiment was noted. So in the observation or for the observation, before the filtration, when the sun was placed into the water and stirred, there was a cloudy appearance. After mixing the sun with the water, the sun separated from the water and settled at the bottom. The visible distinguish between the sun and the water was seen. This means it is a heterogeneous suspension. And after the filtration, after the mixture of sand and water was poured into the filter funnel, the sand particles remain on the filter paper while the water goes through the filter paper into the conical flask. The water was clear and colorless and no sand particle was seen in the water. Are the pictures showing the step-by-step process carried out to separate the sand from the water by filtration. So as you can see, the filter funnel is placed into the conical flask with the filter paper folded neatly, face down to the conical flask. After that, the mixture of sand and water was mixed together with a stirring rod, and then the solution was poured into the filter funnel that contains the filter paper, and as you can see, the sand, which is called the residue, remain onto the filter paper while the water goes through the filter paper and funnel and into the conical flask back to its original appearance, which is clear and white with no visible sand particle. After the experiment was finished, the researcher noted some important questions that should be researched and discussed in the lab report. And as such, in the discussion section, the sand remained on the filter paper because the sand particles were larger than the pore size of the filter paper, so it remained on the filter paper. This allowed the water to pass through and leave the sand particles on the filter paper. The sand particle that remain on the filter paper is called the residue, and the water that passes through the filter paper is called the filtrate. And this was taken from Madhu 2019. An insoluble solute is a solute that do not dissolve in a solvent, example like sand, while a soluble solute is a solute that dissolves in a solvent, for example like sugar or water. And this was taken from Christian Holje in 2023. After that, to conclude the lab, in conclusion, the insoluble solute, which is sand, was separated from the water by filtration. This experiment was successful because the aim of the lab is to separate an insoluble solute, which is sand, from a solvent, which is water, and this was demonstrated clearly. Filtration proved to be an effective method for separating an insoluble solid from a liquid. Now we are on to the second experiment, or experiment number 2, and we are looking at a compound and how it is formed. And the title for this lab is the formation of compound magnesium oxide. The aim is to form a compound from a reaction of magnesium strip and the oxygen in the air. The materials that will be used to conduct this experiment are a Bunsen burner, match, magnesium strip, tongue, and a watch glass. This is a diagram to show the setup of how the reaction between magnesium strip and the oxygen in the air was taking place. So the magnesium strip was held carefully with a tongue and it was placed over the Bunsen burner. And as soon as the magnesium strip formed a dazzling light, it was removed and placed into a watch glass where it settles and forms into ash. This is a step-by-step procedure or method that was used to carry out the experiment. So firstly, the Bunsen burner was set up for the experiment. A clean strip of magnesium ribbon was collected with a crucible tongue. The magnesium strip was heated over the Bunsen burner. The magnesium ignited and burned with a dazzling bright white flame, indicating a rapid reaction with the oxygen in the air, and placed into a watch glass. A white solid ash, which is the magnesium oxide that is formed, was produced and collected after the flame extinguished. The balanced chemical equation for this reaction is 2Mg, which is a solid, plus oxygen, which is a gas, which gives rise to 2 magnesium oxide, which is MgO. Lastly, observations were made regarding the formation of the solid form. After the step-by-step procedure was carried out, observation or results were recorded. As the magnesium strip was placed over the fire, a few minutes after, the strip started to produce a heat and dazzling bright light flame from the fire, and that was placed on the watch glass. The flame turned to a white powdery ash after the reaction of the magnesium reacted with the oxygen in the air was completed. This white powdery ash is magnesium oxide being formed, also known as MgO. So, the bright dazzling flame that was produced from the fire meant that the magnesium strip reacted with the oxygen in the air, and it was removed from the fire and placed onto the watch glass, and it turned into ash, indicating that magnesium oxide is formed. Here are some pictures that was taken out during the experiment. So firstly, the magnesium strip was held with a tongue and it was placed over the fire of the Bunsen burner. Then as the flame was produced, it was quickly removed from the fire and then it was placed on the watch glass and the flame started turning to ash, and that is the magnesium oxide being formed as shown in the two last pictures. After the experiment, the researcher noted some important points from the experiment, and in the discussion question contains it all. After a few minutes, the magnesium strip turned into a bright dazzling light, which indicates the magnesium reacted with the oxygen in the air. So that bright light indicated to the researcher that the magnesium strip has reacted with the oxygen due to the heat. The white ash in the watch glass indicates the formation of magnesium oxide, which is indicated by MgO. The balanced chemical equation for the reaction between the magnesium and oxygen is 2Mg, which is a solid, plus oxygen, which equals to 2MgO, and that is magnesium oxide. And to conclude the final and second lab, a compound was formed by reacting an element, which was magnesium, with another element, which is oxygen, in the air to form a compound, which is magnesium oxide. And that was it for our presentation. We would like to thank you for listening, and